Now, what is a permutation? A permutation is just the arrangement of objects in a specific order. That's always permutation, arranging objects in a specific order. That's it. And so the number of permutations of R objects out of n distinct objects is given by NPR. N in this case is just the number of objects that you have. R is the amount that you want to arrange in order. And NPR is given by this formula n factorial over n minus r factorial. So let's look at this example right here. This says that Ronaldo has 7 Champs Prediction magazines and only has space for 5 books on his shelf. In how many ways can Ronaldo arrange these magazines? So Ronaldo can only arrange 5 out of 7. So that would just be 7 permute 5. That's it. 7 permute 5 would be the number of arrangements. And so you work out 7 permute 5 and you put that in your calculator, 7 permute 5, and you would approximately get 2,520. That's what we would get, 2,520. That's 7 permute 5. So in other words, what we are going to say is, this is what you say afterwards, there are 2,520 ways in which Ronaldo can arrange the books. Nice. Now let's look at it from a different perspective, not just by using the formula. This is like what I like to call the box method or the rectangular method. So this right here is just a box, and what you're going to do is split up the box. You're going to split up the box in different pieces. How many pieces? In this case, you're going to split it up in, this is your R in this case, this is 5. So you're going to split it in 5 boxes. You always split it in R. So 1, 2, 3, 4, 5. This is 5 boxes. All right. Now this right here, look. So this is the shelf. This box represents the shelf. And so what we can say is that if you have 7 books and you can only arrange 5 of them, that means you have 7 books. 1, 2, 3, 4, 5, 6, 7. If you take out this one right here and put it in here, there any one of these 7 can go right here. So yep, so 7 can go here. So then if you take out 1, 6 is going to be left back. So any one of the 6 can go here. Then you take out 1 more, 5 left back. Then you take out 1 more, 4 left back. Then you take out another 1, 3 left back. So in the last space, you're going to have 3 books, and you can take up any one of those 3. And so that means the number of arrangements would end up be equal to, that looks like the 7 times 6 times 5 times 4 times 3. If you work this out, you should get the same as 7 permute 5. 7 times 6 times 5 times 4 times 3. We get 2,520. Nice and easy. So, no issues at all there. Soft. That's how we would do this. All right, so now here's a calculator right here that we can use. So this calculator right here, we're going to use it to help us do calculations, of course. Let's look at another example. This says John Michael has 8 friends coming over his house, but only 4 chairs in his living room. In how many ways can he arrange 4 of his friends to be seated in the living room if the chairs all are in a row? So first thing you have to do is get down your n. This is your n. How much friend coming over? 8. And then how many are you going to be permuting? You only have 4 chair, and so r equal 4. And so what it's going to be is 8 permute 4. 8 permute 4. That's what we're finding. 8 permute 4. So again, we're just going to use our calculator to allow us to work out 8 permute 4. So we go 8 permute. Okay. 8 permute 4. And there we go. 8 permute 4 is 1,680. So that's 8 permute 4, 1,680. Nice and easy and soft. 1,680 is 8 permute 4. Nice. So let's go along now. Now, of course, I always show you the box method as well. So let's look at it from the box method. All right. So the box method is how much chair did that John Michael have? 4. So 1 seat, 2 seat, 3 seat, 4 seat. 8 of the friend them say, yo, what's up, John? John say, well, anyone only can sit here. So any one of the 8 can go here. Then you have 3 seat left back. For this seat now, 7 persons is there. So 7 person can sit here. 6 person fight can get here. Then 5 persons standing up now, and there's only 1 seat left. Oh, so any one of the 5 can sit there. Of course, 4 persons left, but not sit down. But so the number of arrangements would be, in this case, it's just going to be equal to 8 times 7 times 6. 8 times 7 times 6 times 5. That's all it would be working out to be. The number of arrangements. Let me edit that. Would be working out to be 8 times 6 times 5, 8 times 7 times 6 times 5. And if you work that out in your calculator, 8 times 7 times 6 times 5. You put all of this in your calculator, you get the same 1,680. So this, of course, equal 1,680. And that's the definition of permutation. So just to recall, permutation is just the amount of ways of arranging an object or arranging items. All right, and usually you're going to be arranging R amount of items from N objects. All right, where N is just the total amount of objects and R is the amount that you want to arrange. Easy, soft. In doing permutations, there are always going to be permutations with repetition or permutation with restriction. What do we mean by repetition? So permutation with repetition just means that something is being repeated. Some variable or one of the item is being repeated. It's best to see it with an example. Calculate the number of arrangement of the letters of the word additional. Notice that the word additional, this D is being repeated. The I is also being repeated. And A is being repeated. See how much stuff being repeated? There's 1 T here, 1 N, 1 O, 1 L. So see how much letters being repeated? Now how does that benefit us? According to the formula to calculate permutations with repetition, it's n factorial over R1 factorial times R2 factorial times R3 factorial times RK factorial, where R1 plus R2 plus RK equal N. All of this means N is the total amount of objects that you are permuting. In this case, N would be equal to the total amount of letters that we're permuting. How many letters are in additional? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters. So in this case, N equal 10. That would be N. N is the amount of letters that we are permuting. What is next on the menu? The next thing, as we can see now, is the different types of letters that we have there. The different types of letters we have is A. How many A's are there? We can see 1, 2 A's. So we can say how many A's we have is 2. How many D's we have? We have 2 as well. We have 2 D's. Then how many I's we have? 1, 2. We have 2 I's. All right. What else do we have been repeated? D's are repeated, A's are repeated, I's are repeated. Then we have T is just by itself, O is by itself, N is by itself, L is by itself. So those are all one. So you can write down, of course, that your N, there's only one N, there's only one L, there's only one O, and there is only one, what's that other letter? O, N, L, and T. There's only one T. Now, what do I want you to observe? Notice if you're to add up all the different letters, 2, 2, 2, 1, 1, 1, 1, that would give you back 10. These letters would represent your R1, R2, up to RK. So in this case, the number of arrangements of the letters of the word additional is n factorial. So the number of ways would be 10 factorial, 10 factorial, and that is being divided by R1 factorial times R2 factorial times R3 factorial times RK factorial. In this case, it would just be being divided by 2 factorial times 2 factorial times 2 factorial times 1 factorial 4 times. But we don't need to write out the 1 factorial 4 times. If you want, you can. But 1 factorial, we know 1 factorial is just 1. So you just multiplying 1 times 1 times 1. So usually you don't say they write it out. But just since it's our first example, we shall. So it's 1 factorial times 1 factorial times 1 factorial times 1 factorial. Beautiful. Nice. So this is what we have. After we have this now, just put that in your calculator. So let's put it in our calculator right here. So it's going to be put in fraction. It's going to be 10 factorial. 10 factorial. Looking for the factorial sign right here. Here it is. 10 factorial. And that's being divided by 2 factorial times another 2 factorial times another 2 factorial times 1 factorial. But we know the 1 factorial going across will just be 1. All right, let's go back and see what had happened. We put a bracket around them so they know that it's factorials. They're being multiplied by each other. 2 factorial times 2 factorial times 2 factorial. That should do it. That's it. So that's the answer. All of this works out to be equal to, let's check it again, 453,600. So that is 453,600. That's the number of arrangements of the letters of the word additional. So if you want to put that in words, it's always sweet to do it. It's always sweet to say there are ways of arranging. Now here's another example. It says find the number of arrangements of the digits of the number 2221344. First we can see is that this is going to be 1, 2, 3, 4, 5, 6, 7. That's 3, and yeah, that's 7 numbers. So n would be equal to 7. Yeah man, n is 7. So it's just going to be 7 factorial, and 7 factorial is being divided by how many 2's are there? 3. So it's 3 factorial times only one is there, so we can write 1 factorial. How many 3 is there? 1 factorial times how many 4 is there? 2 factorial. And so this would be the answer. That's all. We work this out. Nice and easy, soft. So we work this out and we're good to go. Let's go ahead and work that out. So it's just going to be fraction button 7 factorial, and that's being divided by 3 factorial. I guess I should put it in a bracket. Put it in a bracket 3 factorial times 2 factorial. And you might wonder, why did I skip out the 1 factorial? Because I know 1 times the 3 times the 2 is just 1. That is just, yeah, one doesn't do anything here. So that's 420. So there are 420 ways of arranging the digits of the number 2221344. There are 420 ways. Nice and easy and soft. I always recommend you write a statement. Don't just put the answer as 420. Write a statement. Let them see that you know what you're doing. Example. So this is an example. All right. So just remember, restriction just means something that you have to take out before you can do the permutation. Before you can work out the permutation, you have to take out the restriction part first. Look at this. Find the number of arrangement of the letters of the word singular with all vowels next to each other. So that's a restriction. So if you're to just do it normal, you just look at it and work it out, right? But find the number of arrangements of the letters of the word singular. What you do is just say 1, 2, 3, 4, 5, 6, 7, 8, and say 8 factorial is the answer. No, 8 factorial would be the answer if you just wanted to find the number of permutation of singular. What you're going to have to do is draw your box and find the number of arrangements of this word. First thing you have to ask yourself, 1, 2, 3, 4, 5, 6, 7, 8. How many letters are there? 8. So cut it up into 8 pieces. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. This is 8 box. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, man. Now we get it in 8 boxes because we know n is equal to 8. What is next that we need to do? What is next that we need to do is we need to look at how many vowels are there. How many vowels are there? They said all vowels need to be next to each other. So look at this, 1, 2, 3. There are 3 vowels. So let's say these are where you're going to put the vowels. Doesn't matter, all 3 vowels need to be next to each other. So in this first piece here, it can be either I, U, or A. In this first box here, it can be either I, U, or A, because there are 3 vowels. Nice. And so if you take out one of these vowels, any other of the 2 can go here and then 1 here. Nice. So that's 3 vowels. Now, how many letters are left back? Look at this. How many letters are left back? If you take out 3 letters, 5 letters are left back. And so then you have 5. Any one of the 5 can go here. Any one of the 4 can go here. Any one of the 3 can go here. Any one of the 2 can go here. Any one of the 1 can go here. But Hear the joke part now. Now, since the three vowels them there together, you're gonna think of this as one thing. Think of these three as one thing. So if these three things are think of as one, and then you have five over here, vowels being together, think of together as one. And so this is one and this is five. So overall there are 6 factorial ways. But then it is going to be multiplied by the number of ways we can separate the vowels. As I said, any one of the three can go here, any one of the two here, any one of the one here. So this is 6 factorial times 3 factorial. So that would be the number of permutations of arranging the word singular with all the vowels next to each other. That would be that. That's how we do permutation with restriction. We take out the restriction first and then work out the permutation. And so you would say that the number of arrangements of the word singular with all vowels next to each other is, you work that out, 6 factorial times 3 factorial. Let us check it out. 6 factorial, 6 factorial times 3 factorial. That's 4,320. 4,320. That's it. That's how you do permutation with restriction. Combination is a selection of objects in which the selection order does not matter. Meaning order does not matter in combination. The order in which you select them don't matter. The order in which you select does not matter. Now, n choose r is given by this formula, and this is how we select r amount of objects from n items. For example, calculate the number of ways of choosing 3 letters from the word triangle. It is so easy to choose 3 letters from the word triangle. 1, 2, 3, 4, 5, 6, 7, 8. N equal 8 in this case. And so to choose 3 letters from the word triangle, it is 8, choose 3. So you work out 8, choose 3, and that's it. 8, choose 3, you work that out, and you're good. 8, choose 3. So let us do what is 8, choose 3 right here. 8, then we choose 8, choose 3, 56. That's 56. So that means there are 56 ways of choosing 3 letters from the word triangle. There are 56 ways of choosing 3 letters from the word triangle. Easy, soft, nice. So stay tuned for more. We're gonna stay tuned. Soft.